Hi everybody, this is Dr. Dan Poopery, and in this video I'm going to show you how to use Fusion 360 to go start to finish, where you design a circuit and then design the PCB board for the circuit. And so I'm doing that because you're going to have to do this exact same thing in BME 214L with an ECG circuit. So I'm going to do something that's a little bit simpler than an ECG circuit. I'm going to do an instrumentation amp tester. And that way, when you guys complain that, hey, my instrumentation amp's not working, we could test it in the tester and show you that no, the instrumentation amp is working, it's just your circuit that's not working. Okay, so that's my goal, is to design this instrumentation amp tester. And to do that, I'm going to have, first of all, the voltage supply. I just want to have a single 9-volt battery, not have two 9-volt batteries. And so we're going to use a voltage follower circuit to do this. That will be the same you do for your ECG circuits. And so we'll just use this schematic to draw our voltage follower using our op amp, and then I'll have the instrumentation amp part of the circuit. So let's go ahead and get started. So in Fusion 360, I'm going to go ahead and open the data panel. I'm going to make a new project, which I'll just call like instrumentation amp tester or something like that. And I'll go in here and make a new electronics design. Okay, and we'll make a new schematic. Okay, and so all the parts that you'll need for your ECG and for everything we need for this class, I've made this 214L parts library, which you should have access to because I've shared with you in Fusion Teams. And so these are all the things we're going to need. Okay, for a voltage follower, we need a 9-volt power source, we need 2 resistors, and we need an op amp. And so we can add all those things in Fusion 360. For our power source, we're just going to solder in battery connectors. And so we don't necessarily need anything in particular for that. So I'm going to use the 2-pin connector as our place we're going to solder in the power. Okay, and then we need a couple resistors, which I'll just drag these over here. 2 of them, and we need our op amp. Okay, and if you remember, all our op amp circuits I've drawn with the negative side on top, and you can see this op amp is currently positive side on top. And so I want to be able to get it that way, so the negative side's on top, so that it makes sense when we look at the schematic. So the way to do that is you have to mirror it first, and then you can rotate it around to the proper way. There we go. I can just hit OK. And now I'm going to kind of zoom in. I'm going to also rotate those resistors around so it looks more like this. And so just do that. I can do it this way by giving it like 90-degree angles, or I could go ahead and click that and click on the rotate, and you can rotate it around that way as well. And so we're just going to wire this up just like it says on this schematic, so I can quickly do that. I'm going to use the net here to wire that to that. So sometimes you have to move things around because your dialog box is out of the way, in the way like that, so I just kind of scroll in or out as necessary. Okay, so that's pretty close, but now we just need to wire the actual power itself, right? And so what we see is we have this plus 4.5 volts, okay? We have this minus 4.5 volts, and we have our 0 volts, which is our ground. And so we can do that using some of these symbols so that we don't have all the wires necessarily going everywhere, because we're going to have to power our op amp as well, and so we want to make sure we get the power in the right spots. So we can use the ground right here. Is pretty easy to do. We have our ground symbol that I can just place, and we can hook that up. And for the positive and negative voltage, I'm actually going to use these symbols. So these aren't actually anything, but they will wherever we have one of these, it knows they're supposed to be connected together. Okay, so like for instance, I'm going to go ahead and put this positive voltage right here. I'm going to go ahead and put the negative voltage right there. And I could flip these around to make them pretty if I wanted, but I'm not going to worry about it. And just connect those together, connect these together. Okay, and then if I look at my schematic, I can also see negative voltage connects here, and negative voltage needs to connect to my op amp in the right spot as well. So I can do that by just putting the negative voltage thing down here. And I am going to flip this one around. So I'll hit the rotate on it. And I'm going to put the positive voltage right there. I like just connecting them with wires just because, but I think you can just actually touch those two together and they'll work too. And then we need to do the same thing over here. I'm going to put a positive voltage. It's on this side. You can use my little scrolling around to get things in the right spot. I'm going to flip it around. Okay, this is a little bit painful because I'm actually just flipping around the letter, so you got to make sure you select the actual part itself. There we go. And I'll put the negative here. All right, so I think that is our schematic. It doesn't exactly look like this, but it is correct in that every place this plus V is, you'll have positive 4.5 volts. Every place you have this minus V, you have negative 4.5 volts, right? So we're supplying the op amp with that power, and then we can supply all our other op amps and instrumentation amps with this plus and minus voltage as well. So I'm going to save this file. Now that I've done this, I don't think I need to show you guys how to do the instrumentation amp tester. So I'm just going to like throw it on the schematic. I'm going to stop the video, put it on there, just show you how I connect the instrumentation amp up. And then we will be able to move on to designing the PCB.